Hello and welcome back. So in the last video, we were doing some data restructuring. We were kind of reformatting some data, turning turning wide data into long data. So we've got our wide data here. We actually needed a new column of our grouping variable so we could plot it a little bit easier. And we did that with the gather function here using the tidyverse, okay? Very cool, very cool. And we were able to then plot those differences, and we've got that nice and organized right over here. Okay, now we want to move on to a proper t-test. Okay, but to do that, we need to make sure that our assumptions, that our rules for t-tests are met. Okay, so what is the first assumption here? What's the first rule that we have to meet? Okay, or at least that we have to follow? Well, we have to make sure that everything is numeric, okay? Meaningfully numeric. So let me actually write that. Meaningfully numeric, okay? And we can check that by just sort of thinking, do these numbers here represent something that is continuous or something that is truly numeric, okay? And in this case, yes, they do. They represent the heights of these two different types of fertilized plants, okay, peat plants. For instance, this block variable, this observation number is all this is. These are not necessarily meaningfully numeric because 1 plus 1 here does not equal this, right? This is just saying that, we're just coding categorical things, sort of locations or the block or the time that this was being tested. We're coding them with numbers, okay? But these are not necessarily meaningfully numeric, at least in the same sense that these values here are. So that's good. That's fine. We can also check, as far as coding goes, we can check the structure of our data. If we do that, we can see that we have two numeric columns here. I do this just to make sure that there's not another value in here that's, got 2 periods, 2 decimal points or something like that. If there's a typo like that, the whole thing will be treated as a character, and that's no good, right? So this is just a good check for the overall quality of the data. Okay, and then the second assumption is that they are independent. Which, do we have that? We can assume yes. We'll just assume yes. So there's really no code here. This is all more or less kind of philosophical. We'll assume that these two samples were collected independently from each other, that they're suitably random, and that there's no dependence between the two samples. Okay, so that's easy enough. There's nothing to really check there as far as coding goes. And the last thing we want to check, the third assumption, is are the two samples normal enough? Okay, and so we have a few checks for this. We could plot the histogram of both of these things, and I can do that right here. I'm going to do, is that the right? No, it's not histogram. I think it's just hist. Yeah. I can use a base R histogram for both of the columns. So one at a time. So it's going to be two different codes. I can do a histogram like that for the cross-fertilized species or the cross-fertilized type, and I can do one for the self-fertilized. And now we can already kind of see here that there is quite a different distribution between these two groups. Okay, the cross-fertilized tends, it looks like, to have some higher values for height more consistently, right? So we've got kind of a left skewed distribution here, whereas the self-fertilized is a little bit more kind of consistent as far as what values are there. We have a sort of more normal distribution here. Not totally normal, but normal enough to say that this is probably adequately normal. But this one's not. So what do we do about that? Okay, well, here's the deal. I have put in this playlist, and it's probably the first one you watched because it's the first video there, called Intro to the Central Limit Theorem. It's important that you have an idea of what that idea is, an idea of an idea, but it's all about kind of relating back to what we're doing in statistics. We want a suitably large sample because we're testing means, right? And we know that these samples come from a larger population. And we want to make sure that the mean that we get from both of these groups is at least close to the mean of the population. Totally theoretical, right? It's kind of very much out there. For the purpose of this class, this is very much an applied class. You knowing the ins and outs of the central limit theorem and how differences of means theoretically work is not that important to me. What is important to me is that you at least kind of have an idea of the bigger the better, okay? And in this case, I will say that having 15 observations per fertilizer type, not fertilizer type, per group, we'll say, having 15 is enough. Okay. Now we can also look at the histogram of all of the heights, not differentiating between cross fertilized and self-fertilized. And I can do that with the same code, except I'm using the long data, using the $sign to extract. And now we see here that we get a decently sort of, nothing crazily skewed. This is not too normal, but for right now, we'll say that this is good. Do you have to do this every single time? I will say no. Should you check to make sure that you have at least, a decent size sample for each group? Yes, you should do that. Okay. Now in this case, we have an even, not in this case, in this case, we have an even number of, well, we have the same number of observations per group. Since this is an independent sample, right, we have two separate things. You can't have a plant that is cross-fertilized and self-fertilized, right? These are two different plants. Well, you don't necessarily need a similar size per each one, but it is good to know. It is good to know that we have at least, something that's big enough for each category here, each column, each group, we'll say, and that's fine. So always check to make sure everything is meaningfully numeric and everything is actually numeric. And then independent, you can pretty much always assume that in this class. When you're out in the real world, this is something you want to check by just asking the person who collected the data how they collected it, if it's suitably random, that kind of stuff. And then normal enough, you can either look at the histograms per group and in total, or you can just look at the total number of, or the number of observations per group. 15 in my mind is good enough. Okay. So I'm not too worried about these histograms here looking kind of janky. Okay. We've got a sample size. I think that is large enough to at least make some kind of intro conclusions about our population here. Okay, now let me actually kind of go back to the PowerPoint here on my other screen. Do I want to? Okay, we've checked the assumptions. I'm going to start a new video to actually show you how to do it at t-test. Okay, so with that, I'll see you in the next one.